So what we're looking at here, it's a presentation today on wastewater heat recovery, predominantly looking at new build housing and how wastewater heat recovery can be incorporated into Part L 2021. Brief introduction, a look at wastewater heat recovery as a technology overview, a little bit of focus onto the main product types that we have, then onto why wastewater heat recovery is important for Part L and future homes, a bit of a whistle-stop tour on Part L and how wastewater heat recovery can impact that. As well, then we'll look onto a little bit on designing in wastewater heat recovery, and if we have any SAP assessors in the room, a very brief overview on how to SAP model. It is a very brief overview. And then finally, a case study at the end, and hopefully some time for Q&A as well, if we haven't answered all the questions as we go through. So who uses wastewater heat recovery? Well, in the main in the UK, wastewater heat recovery is predominantly used by new build house builders and developers, and it has historically been used as part of the Part L compliance package. So with Part L 2023, which is the previous regs, it was used by some developers as part of standard spec, but more often than not ad hoc, where perhaps local authorities or councils were asking for an uplift over standard regs. However, with the advent of Part L 2021, that looks to be changing, and we'll come into that as we go through. But it's important to say that wastewater heat recovery, whilst commonly thought of as a technology usable in standard new build housing, we do also have products that are suitable for houses, for apartments, for bungalows, passive house, etc. So essentially, if there's a shower in the environment, we tend to have a wastewater heat recovery unit that will work for it. But in addition to housing, also with changes in new build Part L regulation for non-residential, we're seeing a much bigger uplift on student and hotel accommodation projects. Also anywhere where there's high shower traffic, so leisure and sports facilities, certainly changing rooms, new build sports facilities, even sort of 106 agreements alongside housing developments where there may be community changing rooms and things like that. So certainly a lot more interest on the non-residential side. And then as we look towards the future, the expectation is that housing stock upgrades and retrofit, domestic retrofit, will become a much bigger component for wastewater heat recovery going forwards, as the funded drivers, so eco, etc., catch up and allow for non-space heating measures to be used. Then wastewater heat recovery really will be a low-hanging fruit there, almost equivalent to loft insulation, for example. So we see this as a very big growth area going forwards. So why use wastewater heat recovery? Well, it will significantly reduce energy demand and consequently CO2 reductions for any new build with showers. It's very easy to incorporate into new build with very little adaptation, and we'll kind of look at that as we go through. And it provides simple, cost-effective Part L compliance. So Part L compliance is obviously important for energy efficiency specification, and it's one of the cheapest and most cost-effective measures available in the SAP database. So it really is a no-brainer when it comes to the Part L compliance element. But from an end user point of view, from a real-world usage, it can provide significant energy demand reduction for showering, so up to around about 55% in a standard new build home, and we'll qualify that as we go through. So either using less hot water per shower and or less energy required to produce hot water. And importantly, there's no end user interaction required with wastewater heat recovery. So your homeowner or your tenant won't know that wastewater heat recovery is installed in most cases. It doesn't impact the shower flow rate. It doesn't impact the temperature and the showering experience. But importantly, from an energy saving point of view, it can't be switched off. There's no isolator switches. It will always work as soon as the shower's switched on. It's passive, instantaneous energy saving. So I mentioned that it's very easy to design in. Essentially, because it has no moving or mechanical parts, no electrical connections, and no buttons to press, it's a fit and forget product, so completely passive. And it has a very long working lifespan because of that. So BAEs attribute a 40 to 60 year working lifespan for the vertical pipe systems, and around about 25 years for the horizontal systems, quite simply because they haven't been in the market as long, so they don't have quite as much of a pedigree. But for all intents and purposes, wastewater heat recovery has a lifespan in line with the plumbing infrastructure. And also, not quite as important in SAP 10, but certainly looking to the future, and for SAP 11, we offer a very low embodied carbon within our product. So, and we can qualify that hopefully with a couple of slides at the end. Just for anybody that's coming late, just to mention that fit to frame, if you click the 3 dots on your Teams and fit to frame, you should get the full screen. So, excuse me, just one second. Just a quick look at the products in more detail. So Recoup have a full portfolio of wastewater heat recovery products. The main product for new build housing is a vertical pipe system, and we'll just give a quick overview on how wastewater heat recovery works there and base that around the pipe. So an animation here, which hopefully you can see loading up. So what we are looking at as that kicks in is a standard house type with first floor showers. So shower on the first floor, and as you can see, wastewater heat recovery located underneath that. So this is a passive wastewater heat recovery pipe, which is gravity fed on the waste side, cold mains pressure driven on the cold side. So without wastewater heat recovery, your standard shower with a thermostatic mixer will deliver a kind of comfortable 40-degree temperature at the shower head, which is a mix of about a 50-50 ratio of generated hot water at about 60 degrees, 55, 60 degrees, and incoming cold water main 50% at about 10 or 12 degrees. And that 50-50 mix is controlled by the thermostatic mixer. And from a wastewater heat recovery point of view, for SAP compliance, we always require a thermostatic mixer. It's what's controlling the preheated water as it goes in. So of that comfortable 40 degrees coming out the shower head, normally around about 85 to 90% of the heat energy from the shower head will go down the drain and be lost from the building. So there's a big energy loss with showering, and hot water being an expensive thing to heat up, it's potentially a big loss from any home. With wastewater heat recovery attached, as you can see here, the vertical pipe system or the wastewater heat recovery pipe sits on the outgoing shower waste. So we've got warm shower waste running through one side of a heat exchanger. And then at the same time, when you switch the shower on and that warm waste starts going down, cold water's drawn through and goes around the outside or on the opposite side of the heat exchanger, and that's preheated. So where that cold water might be going in at around about 10 or 12 degrees, it will be preheated up to about 25 to 28 degrees. And quite simply, that is wastewater heat recovery in a nutshell. However, under SAP, there are 3 recognized installation methods, and we'll just kind of qualify those now, but they're all to do with where the preheat is fed within the hot water system. So if I just move this on one slide. So looking at the same, just a still of the same slide here, but with a pipework schematic here. So system A, which is what we're looking at here, is the most efficient method of installing wastewater heat recovery or designing in wastewater heat recovery. And quite simply, that cold water main that goes through is preheated, and then we will direct that to both the cold side of the shower mixer and back to the hot water source, whatever that may be. Now, by sending preheated water to the cold side of the thermostatic mixer, instead of that 50-50 ratio of hot to cold, the thermostatic mixer will automatically adjust the ratio in favor of more of the free issue cold to about a 75-25 ratio. So immediately we're using less hot water per shower use. But also by teeing off and sending preheated water back to the hot water source, in this case we're showing a cylinder, but it really can be any hot water source. We're technology agnostic and fuel agnostic in that respect. So heat interface unit, combi boiler, cylinder, thermal store, electric boiler, air source heat pump, it really doesn't matter as long as there's a thermostatic mixer in place. but by sending preheat back to your hot water source, so in this case the cylinder, the boiler isn't having to work as hard to heat from 10 degrees up to 60, it's now heating from about 25 up to 60. So system A uses less hot water per shower, and the hot water we are using is produced more efficiently. So that's the most efficient method of installation. System B, quite simply, sends the preheated water to the cold side of the shower mixer. So we're just using less hot water per shower. This is a simpler method of installation, and it's normally the method used whenever there are secondary wastewater heat recovery units. So as a primary, we'll look at system A. Any secondary wastewater heat recovery units installed would be system B. And then just for completeness, system C, as you've probably guessed, sends the preheat just to the hot water source only. This isn't seen too often in residential, but for instance, if we had a townhouse scenario where you've got a stacked second floor shower and then a first floor shower, a pipe located on the ground floor, often from a pipework point of view, it's easier and less cost to simply just feed through and feed to the hot water source, which may be a cylinder located, for instance, in a utility room on the ground floor. So system C used less often. It actually sits in between A and B in terms of efficiency. But just to qualify the impact that wastewater heat recovery can have on those system A and system B, so the two ends of the spectrum there, the pipe has a heat recovery efficiency which will increase as the shower flow rate decreases, and quite fortunately now new SAP, so SAP 10 allows for specification of flow rates. So you can have where historically the default shower flow rate was 11 litres per minute. Specified can now specify anywhere down to 6 litres per minute. So the heat recovery efficiency of the wastewater heat recovery will be modelled more efficient with slower flow rates. But just to give a kind of the common shower flow rates here, 11 litres per minute and 9 litres per minute, you can see the efficiency of the system goes from 63.6 up to 68.1, but the energy demand reduction, so the real impact that wastewater heat recovery is having on the whole system there, is around about 55 to 58%. So obviously we're working on that 85% of the heat energy that goes down the drain. So it's not the full efficiency, but it's very, very significant in terms of energy reduction. And then just to contrast that with system B, this is purely hot water reduction because we're just on the cold side for the cold side of the shower. So at 11 litres per minute, around about 40% hot water reduction, and at 9 litres per minute, around about 43%. So it really is quite significant, and we'll kind of delve into that in a little bit more detail as we go through. So I'll just pause there just to see if there are any questions coming in, JB, regarding that section. I'll look at products in a bit more detail in a moment.
No, nothing come through as yet, so
okay,
doing a good job.
Great stuff, thank you. So just to look at the main product type. So Recoup have a full portfolio of wastewater heat recovery products, and in the main, the vertical pipe is the ideal product for new build housing. The reason being, it's the most efficient product that we have in our portfolio, but also one of the most efficient products on the SAP database. So it really does score very highly in SAP, especially considering the low installed cost. It's a 2-meter vertical pipe. As I said earlier, it's gravity fed on the waste side and cold mains pressure on the cold side. So it needs to install on the floor below the shower it's connected to. So as you can see here, this is boxed in under a shower behind some kitchen units. Very high heat recovery efficiency, in part because of the way that the unit is designed, the length of the heat exchanger, but also additional efficiency is gained using our turbo rotator. And that's quite simply, as you can see with the yellow waste coming in, that's used just to direct the flow of the warm waste so that it can then cling to the inside of the wastewater heat recovery pipe, giving us what's called thin film heat exchange. So we're maximizing the surface contact of the warm waste with the heat exchanger. It's normally installed at first fix. It's very simple first fix installation. Really very little required other than what we supply in the pack. So we're showing here the wastewater heat recovery pipe, the installation kit, and then all that's needed for most installations in addition are 2 isolator valves, 1 top, 1 bottom, and a double check valve for water regs compliance. It really is as simple as that. And as I said, first fixed installation, pressure tested when the hot water system comes into play, and that's it. It's installed, no commissioning, nothing else required. And as I said earlier, it really takes up very little in terms of changes to existing design. So we're boxing in next to the SVP. So in most cases where your SVP pipe boxing might be around about 220 by 220 mil, with wastewater heat recovery included, it adds about 200 mil in one direction on the SVP boxing. So it really does take up very little floor space. It's not necessarily known to the homeowner that it's there. It's very low profile. It really isn't sort of next to invisible, essentially. All of Recoup's wastewater heat recovery products have double-walled heat exchangers. We use double-walled heat exchangers because they give us a visible leak detection system, which means that we're directly compliant with UK water regulations. Sorry, I've just seen that question come up. Directly compliant with UK water regulations. What it also means in practice, if we had a single-walled exchanger, the shower trap from underneath the shower would need to be moved downstream and underneath the wastewater heat recovery unit. That potentially means that you would have to have access hatches in place so that you can access the shower trap. It also means obviously the shower trap is potentially designed to block, or would be a point of blocking. So it would mean that the wastewater heat recovery unit needs to be accessible. Now these are devices, so they need to be reasonably accessible. However, if it was boxed in behind plasterboard, that would be deemed reasonably accessible. It doesn't require any planned maintenance. There's no serviceable components in there, no electrical, no mechanical, no filters, no consumables. So it can just sit in and literally be fit and forget. Once it's pressure tested, that's it. It will sit there. There's nothing realistically to go wrong with the unit. So in answer to the question that popped up there, essentially there's no access required in most cases. And then just on the pipe system, so our products are stocked and sold by all of the main UK plumbing and heating merchants. It means that we can dovetail very easily into existing supply chains, into developer supply chains, and also offer contract supported prices and things for volume developers. So just very quickly over an overview on installation operation. As I said, very simple to install. So realistically at first fix, 1 to 2 hours installation time, depending on that installation method, size of property, etc. Only basic plumbing tools and materials required, basic plumbing knowledge required. So there's no specialist training, there's no commissioning, there's no MCS accreditation or anything along those lines. And then also no planned maintenance required, just simple routine cleaning. The same sort of thing, same cleaning regime that would be required for any sort of shower waste pipe work. So normal drain cleaners, we can, it's wide enough to accept a plumber's brush. There's no bottlenecks within the system. So very simple cleaning if required at all. And very importantly, as I said earlier, no behavioural changes. So it can't be isolated, it can't be turned off. It will just work every time the shower is used. And as such, it really does plug that compliance gap between as designed and in use very well. So the pipe system, as I said, is the one that we'd look to ideally specify because it is the most cost effective and it's the highest efficiency system for new build housing in most cases. But the negative on it is it does need to locate on the floor below the shower it attaches to. So obviously for ground floor showers, for apartments, and possibly for modular, it might not be the ideal solution. So we have other products in the portfolio which then allow for that. So the next most cost-effective solution in most cases is the Easy Fit. This is designed as an underbath system, but can also install under suitably sized shower riser trays. And quite simply, it's a horizontal wastewater heat recovery unit, which just fits into the unused void space under a bath. Again, very simple to install, simply warm waste flowing through, cold water main coming through and being preheated. By the nature of their design, horizontal systems aren't quite as efficient as vertical systems. So this is around about 2/3 the efficiency of the pipe system, although priced very similarly. So it's very cost effective in the market, and can also be used for commonly used for apartments, retrofit ground floor, and certainly can be used for showers. Very simple to install, same simple method of installation in that the warm shower waste goes in one side of the unit. In this case, it actually floods out onto the bottom of the wastewater heat recovery pan, so the bottom of the casing, and then flows through the unit. At the same time, again, cold water is drawn through. In this case, we have a kind of serpentine heat exchanger, which sits about 2 millimeters above the floor pan of the unit, so that if any debris do come through from the shower trap, they simply just flow straight through. But more importantly, at standard shower flow rates, there's lots of mixing, lots of turbulation, and therefore lots of heat exchange pickup. And so then that cold water main comes through and is preheated and just feeds off to the shower or the shower over bath as normal. The way that SAP calculates hot water use in apartments, although the EasyFit is a less efficient product, quite often it will score very similarly to the vertical system in houses. So if you are looking at apartments, this really is a good system to look at because it does score very well in SAP. And then just introduced this quarter, we've introduced what we're calling the Pipe Hex Active, or an active upgrade kit for our current vertical pipe. As I said, the vertical pipe normally would need to be installed on the floor below the shower it's connected to, so it's a passive system. But by teaming it up with a pipe and a proprietary buffer tank, it means that the pipe can install on the same floor as the shower it's connected to. Now, this is very useful for apartments or DDA enabled bathrooms where you've got very low profile shower trays. So certainly it's much more common now to see low profile shower trays specified, especially in apartments. So this solution is ideal there. It means that the wastewater heat recovery unit stays within the bathroom footprint, but also within the footprint of the apartment that it's connected to. So there's no ownership issues and things. So just very quickly to go over this. This has just been SAP listed this month and is now available through the merchants as an upgrade kit to our existing SAP listed pipe. So just hopefully you can see the schematic there. So it's a little bit of a line drawing, but essentially the pump system just takes the warm waste from the shower, just flows into the pump. This activates the flow switch in the pump, which will pump it up over into the buffer tank. And then that buffer tank has a turbo rotator within it that will drop that warm water through the unit, and then it flows off to the SVP as normal. So it's functioning exactly the same way, apart from it's got a lift pump. What I will say though, the way that the buffer system's designed is so that the pump only has to work for about 1/3 of the time that the shower's in operation. So it will pump up and then it will stop and then it will drain through and then it will pump up and over again. So it means that although we've got a very low wattage pump already installed, about 250 watts, the pump is actually only working for about 1/3 of the time. So it means per shower, it's around about 90 watts per shower. So it really is very, very low. In fact, so low that in the SAP listing, they haven't had to take any efficiency off for the presence of the shower. It's also very flexible. So you probably can't see that there, but if I move on to an exploded view, we can be anywhere from around about 1 to 3 meters distance from the shower with this system. So it's a little more complicated to design in, and we can obviously assist you with that. But it does mean that it's very flexible in terms of design. Obviously, I've mentioned that the wastewater heat recovery unit itself is essentially is planned maintenance free, so that can be boxed in, for instance, behind the shower. But the pump, because it is a mechanical component, does need to be accessible. So this, for instance, can locate maybe in a service void underneath the vanity unit or boxed in next to the shower. So it does give some flexibility in terms of where the pump is located in respect to the pipe. And as I mentioned, it's just been SAP listed and it has the same efficiency as the existing pipe. So it's a really nice way that we're leveraging the efficiency of the vertical pipe system, but allowing that now to be used in apartments and ground floor showers and things. And certainly with the increased efficiency requirements for Part L, which we'll look at in a moment, it really is a great product for apartments. Then just to complete the range, we also have a range of wastewater heat recovery integrated wet room drains. These range in efficiency from around about 40% up to about 57%, so they're quite a range. And they are essentially linear wet room drains with the wastewater heat recovery components included within that. So everything is accessible from the surface. So the drain plate can be moved and everything's completely accessible for ongoing cleaning, etc., etc. But again, realistically, no planned maintenance required over and above anything that you would normally have for a linear shower drain. These aren't really seen so much in residential, but certainly for non-residential, for commercial, for leisure, etc., where you've got high shower traffic, these offer fantastic ROI. Different products for different areas. So this is showing a tiling cover. So if you are designing into commercial wet rooms where you need to have the slip resistance maintained from the finished floor to the drain cover, this is absolutely ideal. But also we have, from an aesthetic point of view, we have the brushed stainless steel cover as well. But yeah, high shower traffic, if you're looking at anything that's non-residential with linear bathrooms, linear shower rooms, then these are absolutely ideal and really low ROI. Sorry, I'll just pause there. That's sort of as much as we'll go into on the product side, just to see if there are any questions, James.
Nothing further at this stage.
Great stuff, thank you. So
Text as a board, this one just popped in there. I don't know if to, should I read that out?
Yeah, if you don't mind.
So, question: vertical pipe system A, could then the preheated water be taken to other cold feeds in the dwelling, or is it limited to the shower tray it's installed for?
No, it has to go to the cold side of the shower, and if it's system A, it's going back to the hot water source. So the cold water feed that would normally feed, for instance, the cylinder, will be routed through the wastewater heat recovery unit and back. It means that in practice, when the shower's on, that's when we're getting a preheated feed to the hot water system and back to the shower as well. So we rely on that warm waste going down because that's our only heat source, and cold water main coming in to be preheated. So whilst technically you could feed it to other areas and it wouldn't be SAP compliant that way, but you know, it could be done, but you wouldn't get any benefit. So for instance, with a shower over bath, you're only getting a benefit of wastewater heat recovery when the shower's running. When the bath is filled up, there's nowhere, and you sit in the bath and it goes a bit cooler, and then you pull the plug, there's nowhere for that heat energy to go unless you just happen to be, you know, using the refilling the hot water tank or something at the time. So SAP doesn't recognize or doesn't attribute any energy savings to the bath. It's only to the shower only, and that's the same with all other hot water outlets. It's because our heat source is that warm shower waste going down the drain. It's only used in that cycle of when there's warm waste going down and cold water main coming in. Hopefully that answers okay. So just to look at why is wastewater heat recovery, I mean, we've kind of looked at the significance of the unit in terms of heat energy, but how does this look on a sort of wider scale? Well, in most average homes, if we're looking here at sort of a energy mix breakdown from a average UK home, data from Energy Saving Trust about 15 years ago, majority, about 2/3 of the energy use in the home is for space heating, with about 18 to 23% on water heating. And of that generated hot water in the home, about 50%, certainly in houses, is attributed to showering. That can be anywhere up to about 80% for apartments, but generally for showering, attributed about 50%. And as I mentioned earlier, about 85 to 90% of that heat energy from the shower is going down the drain and going out of the building. So it's the equivalent to having your heating on and having a window open continuously. You just wouldn't do it realistically in a home. So it's a big energy loss from the building. So when we look at putting those in that same energy mix or that same average home, you could be looking at around about 10% of the energy being wasted without wastewater heat recovery. So it really is quite significant. And more significantly, when we look at this under the energy mix for homes being built to current regs, so Part L 2021, effectively, because of increases in air tightness and fabric efficiency, the space heating demand is going down. And even if the actual amount of hot water use isn't going up, the relative percentage is going up, and therefore there's potentially more energy as a percentage being lost from new build homes due to not having wastewater heat recovery. So it really is quite important. As we look at the new regulations, so Future Homes 2025, the plan there is to move away from fossil fuels, look at a much tighter energy efficiency measures, so that with more efficient fabric, it lowers energy demand, so a 75% lower CO2 emissions for new homes built from 2025. But because the plan is to have all new homes being fully electric, as the grid decarbonises with more and more renewables coming online, ultimately those new homes built from 2025 won't have to be retrofitted. They will naturally move down to be net zero as the grid decarbonises. So that's the main ethos, if you like, for Future Home Standard 2025. However, the question might be, why don't we just move to all electric straight away and move to renewables as quick as possible? The issue is at the moment is that the grid really doesn't have the demand. So if we look at the energy demand for new build housing versus the grid supply, we can see that the peak energy demand that's required for hot water and heating in new build homes is around about 170 gigawatts through gas, and the grid capacity is around about 60 gigawatts. So the reality is we need a much bigger demand reduction in homes across the board. So obviously this is not just for new build, this is for all homes, all 24 million homes in the UK, before we can completely move across to all electric. So it does present a big problem. However, as I said, the wastewater heat recovery can reduce that hot water demand very quickly and very significantly certainly in new homes, and then hopefully as we move on into retrofit, as we said. But the ethos for Future Homes is that none of the homes built from 2025 should need to be retrofitted. So it's kind of taking them out of that retrofit problem, and that's the real driver for 2025. However, in the meantime, we have the stepping stone regulations, the Part L 2021, which are the current regulations, went live in June of this year, and with a 1-year transition. So from June 2023 next year, all new homes built in England, and the regulations for Scotland and Wales are in the mix as well. So they will follow suit shortly. But essentially all new homes for England will need to be built to Part L 2021. So it's a big change, and it's a fast change, because we're looking at an increase of 31% CO2 reduction and a big reduction in essentially energy demand at the front end, and a kind of lesser requirement on PV, because the grid is already decarbonising versus last SAP from previous regulations. So what does this mean for wastewater heat recovery? Well, for the first time, and it seems that the regulations kind of potentially catching up here, is the first time that wastewater heat recovery has been included on the notional dwelling. So this is the BAE's recipe for the most cost-effective route to Part L compliance. So it's the standard recipe for compliance for most house builders. So whilst we've said that electrification from 2025 is going to be key, gas boilers are still permitted under the Part L 2021 regulations, and the expectation is around about 80 to 90% of new homes will still be built using gas boilers. Obviously heat pumps are available, and heat pumps will give good compliance in SAP under current regs or the current regs now. However, when you consider there's probably around about 180,000 new homes going to be produced in England alone, and there's only around about 60,000 heat pumps being installed per year, and that's up from around about 30,000 in previous years, there really isn't either the supply or the skills available for everything to go to heat pump right now. And then obviously we've also got that energy demand and things as well. So the expectation is that gas boilers will still dominate going forwards, and therefore that most cost-effective recipe of fabric efficiency, thermal bridging, wastewater heat recovery with gas boiler and PV is looking to be the most cost effective. And there was some work done by by BAYS and Ministry of Homes, Communities and local government, looking at the costs and the extra costs for heat pumps and things. Now, obviously, that will go down as the supply chain gears up towards more heat pumps, but at the moment, this is the most cost-effective recipe. So what are we seeing at the moment? Well, we're seeing a number of certainly volume developers looking at wastewater heat recovery as part of their standard spec. We've been very lucky to work quite closely with BARRATT. We've been sole supplier to BARRATT now since 2013 and work very closely with a group technical on their standard spec going forwards, not just into 2021, but they're also looking at using wastewater heat recovery going forwards. And we've got a case study towards the end that we'll look at there as well. But also a number of the larger developers are looking at wastewater heat recovery as part of their standard spec. The reason being, it allows that use of known and available technologies, gas, PV, wastewater heat recovery and fabrics. So there's not big changes to supply chain, to installation, installers, to knowledge, etc. So it really is a good stepping stone. It also allows the adaptation of a simpler adaptation of existing house types. So this is just a quick snapshot table from the Future Homes Hub, and they've looked at a number of different house types and a number of different fabric builds, so masonry, timber frame, etc., with different cavity types. So looking at kind of standard spec and cavities for previous regulations, for 2021 notional dwellings, and also for future home standard fabric, and looking at the best ways to get compliance and using different gas boilers, all electric and air source heat pumps and things. And what's quite telling is that wastewater heat recovery is used across the board on all of those. So this is independent think tank data, which we'll put a link to in the video description on this one as well. But it really shows that wastewater heat recovery is being considered for that energy demand reduction, even with air source, where secondary benefits might be reduction in size of hot water tanks, reduced cycling, smaller plant, etc., etc. So it's certainly worth considering, not just for gas boilers, but if you are looking at air source and all electric heating as well. But obviously with the use of gas boilers, it does mean that there's an easier infrastructure transition, certainly on bigger developments, crossing across different Part L regulations. And also wastewater heat recovery is a fully scalable technology. So certainly with Recoup, we have the ability to scale from what's a relatively niche product in the UK marketplace to something that is fully scalable and used by all of the top 20 volume house builders. So it's certainly a very scalable technology. And as we said, it really should form part of that most cost-effective package of measures. Sorry, it's a bit of a whistle stop, that one, because there's so much more involved in Part L and certainly future homes and things. But I just want to kind of highlight where wastewater heat recovery adds benefit there. Again, just a quick question check before we move on.
Yeah, we've had a couple of questions in. Brian Murphy has asked, do we have an improved installer scheme, and also what skills we needed, whether skilled tradesperson or competent DIY could potentially fit one of these units? Yeah,
absolutely. So yes, I'll answer on James's behalf actually, because it falls under James's remit. But we are looking at developing an approved installer scheme at the moment. To complement that, and we have this already, we have a Recoup learning site which is just dedicated to installer learning journeys, videos, all sorts of resource there. But yet we also have, from a DIYer point of view, we have short and long installation videos, step-by-step instruction manuals, lots and lots of resource showing exactly how to put these things in. But they really, I mean, it really is very simple, and certainly an easy fit being installed under a bath as System B is realistically probably a couple of hours of DIYer time in most cases, someone who's relatively competent with plumbing tools. So yes, we have all of that, and we are developing an improved installer scheme to go forwards with. And certainly if you're a volume developer or a developer, we have the facilities in-house to produce training videos for you, walkthroughs, and I'll try and show you the studio that I'm in a moment, where we've got essentially an in-house exhibition centre where we can produce training videos and things for you. Was that the only question, Joby?
There was one more, more of an observation more than anything. So Marcel has brought attention that in the EU, the average hot water shower usage is somewhere between 70 to 80%, and just wondering why our figures are based on the 50% usage.
I will answer it, but I lost you quite a way through that, JB, sorry.
Okay, sorry. Yeah, how much did you hear? So basically, I'll go over it again. So Marcel has brought to our attention that in the EU, they work hot water usage based on 70 to 80% in the home rather than the 50% that we showed in our diagram. So just wondered, yeah, why?
Yeah, it's a good point. I think a lot of EU tends to be certainly more apartments, so that may have an impact there. And I think certainly I think the UK is quite novel in the fact that we have historically baths, then showers over baths, and then now a bit more of a movement towards showers. So I think certainly in apartments, I think that sort of percentage would be correct. Yes. Okay, so just a quick overview. I'm a bit conscious we're running close to the time. So an overview on designing in wastewater heat recovery, and essentially the real takeaway from this is lean on us for support. I mean, wastewater heat recovery is relatively simple for most standard house types, most standard apartment types, and we'll go over that very briefly here. But if you're looking to design wastewater heat recovery, if you're considering it for group spec or just a development, or even just as a self-builder, feel free to send us your floor plans across. We'll go through it. We'll come back with a list of options for you. We have a technical team here, and that's pretty much the 90% of what they do day to day. So feel free to lean on us. But yeah, essentially wastewater heat recovery is a simple technology to design in. And for apartments, 2 and 3 bedroom homes, the biggest impact is normally from a single pipe installed to the master ensuite as system A, and in most cases that will give the biggest uplift and certainly the biggest bang for your buck in terms of SAP points. Larger houses may require 2 or more, depending on how many showers and how big they are. So again, normally it will be system A on the primary shower, whichever you may deem the primary shower to be, and then any secondary showers installed as a pipe with system B or one of the other units if the pipe doesn't work, so maybe the easy fit or the active. And if you can consider wastewater heat recovery in your design at early stage, so if you're an architect or specifier, if there's the ability maybe to put bathrooms and shower room back to back, quite often you can route both of those units through a single pipe, and that obviously reduces costs. So again, we can advise on that, we can advise on the limitations, and hopefully get you the most cost-effective solution each time. So just a very quick run through in terms of the SAP impact on this is just a standard 3 bedroom, 2 bathroom property with a shower on the master ensuite and a bath only on the family bathroom. So as I mentioned here, the obvious choice here is the pipe installed as system A to the primary shower. This is just an example of some of the data we would send back. So we normally give a tabulated list of wastewater heat recovery options. Obviously for this one, it's relatively simple. But what we'll always put in is specification notes. So as a specifier, you understand why we're specifying something and what the relative benefits are. And also with a kind of a MBS style specification, which you can attach to the drawings so it follows through. Also design and installation notes. So if it's a complicated or more complicated proposition, we'll have installation notes so the installer knows exactly what's been installed to where and why, and any other elements that maybe need to be considered. And also for the SAP assessors, we'll always put the PCDB number in, so it means rather than having to search through the entire list of SAP listed products, you can just pop the number in and it will put it into your spec for you, into the modelling. And talking of modelling, I did mention I'd go over this quickly. I'm not sure how many SAP assessors we'll have in the room, so I'll just glance over this. But again, come back to us if you want a bit more detail. But so SAP 10.2 appears to be working very well now. Seems that most developers are happily modelling or SAP assessors modelling for developers now. But essentially, to put wastewater heat recovery in, it's relatively simple. Goes into the hot water area, obviously, which is 28. You need to select the correct product, so you can pop in the PCDB number or select the product there. And then the important bit is you need to say whether there's a bath or present or number of baths that are present. And And then also you need to click to add the showers and connect them to any wastewater heat recovery units that you've put in. So you may specify, for instance, two wastewater heat recovery pipes, one as system A, one as system B, but you need to click this add button to attach the showers and specify the flow rate. So the flow rate specification is really key and can really impact SAP quite a lot on this as well. So yeah, quite simply just add in the showers, connect them to a wastewater heat recovery unit, and then click this checkbox here, and it's all connected, and then that will output the wastewater heat recovery. So if we just go back to that 3-bed, 2-bathroom scenario that we just looked at, if we look here, so we're highlighting that a 3-bedroom mid-terrace and a 3-bedroom detached. And as you can see, the impact highlighted there from primary energy, around 10.7, 10.8% energy reduction due to the installation of the wastewater heat recovery unit system A on that primary shower, and also a CO2 reduction of around about 11%. And again, if you can remember back to the pie charts, that ties in quite nicely with some of the expected energy losses that we were saying that you get through showering. So it really does seem to be working quite well for wastewater heat recovery and energy modelling at the moment. For most cases, SAP modelling is enough for new build dwellings, but if you do have any projects where you're looking and you require a more granular look at energy savings, at the direct energy savings, at CO2 reductions, etc., we can give full granularity for instance, non-residential projects, for retrofit projects, or even just as a developer if you really want to understand the impact a bit more. So I won't dwell on this too much, but obviously we'll supply the presentation afterwards, so you can look at this as much as you need to. But what I will draw your attention to is just the annual CO2 reduction from wastewater heat recovery here, which I can't quite see on my screen, which with gas is 164 kilograms a year, and we'll pick out air source heat pump at 131 kilograms a year. I'll bring that back to kind of frame that against the embodied carbon in the product in a moment. So as I mentioned, we have a very low embodied carbon in our wastewater heat recovery products, in part because we use a lot of copper, which is 100% recyclable, and our native copper is 70% recycled. And we have full traceability back there with Copper Mark responsibly sourced copper. But also we operate a cradle-to-cradle circular manufacturing process. And also we offer buyback scheme for end-of-life products, and also faulty or transport damaged products, we will offer a credit back so that we can remanufacture those if the exchanges aren't damaged. So we use circular supply, and so we worked with TM65, with SIBSI on developing their TM65 embodied carbon standard, and therefore supplied our data to them. And what we finished up with was an embodied carbon score of 59.63 kilograms per product. Now, if we relate that back to those operational savings per year against gas, air source and electric, you can see it really is quite insignificant. So the embodied carbon in the product could potentially be outweighed by the operational savings within 4 to 6 months in most cases. So it really is very low. And when you consider that impact against maybe things like air source, against PV and other measures, whilst we're not looking at technically replacing them, we have a very low embodied carbon by comparison. So that's about as far as we'll go with that for now, but we can talk embodied carbon if anybody has sustainability questions. And then just to look at a quick overview, again, because I'm right about time here, on the apartments. So if you're looking at a standard apartment, you may well have a shower over bath as your primary. So the Recoup EasyFit installed as System A is probably going to give the biggest uplift there from a SAP point of view. But also you may have a master ensuite with a shower. So you could look at the Hex Active either as System A as the primary shower, or in conjunction with the EasyFit as System B, or maybe swap the System A and B around depending on which showers are going to be used the most. So again, as I said, we have solutions there, and again, relatively simple to install, but lean on us as much as you need to. I just mentioned a case study. So we have lots and lots of case studies. We've been in the market now for 11 years in the UK, so lots of residential case studies and used by most developers, certainly at development level. But I wanted to highlight the BARRATT Z House, which is a exemplar house build that BARRATT have put together using around about 40 in the market now sustainability technologies and measures looking not just on energy efficiency but also on biodiversity and general sustainability, and essentially they've put together a house which is based on one of their existing homes and upgraded so that it can be net zero ready now. So it really is quite an achievement, but from a wastewater heat recovery point of view, this the home has used our wastewater heat recovery, so it's used the pipe hex installed in this case to both the master ensuite shower and connected to the shower over bath, so they're designed in back to back, and also interestingly using on the main shower a Kelder low flow shower, which is kind of a newer technology which gives aerated shower, so it's a good experience but low flow, and we're working very well with that. And then a standard reduced flow rate shower just with flow restrictor on the main bathroom, and also used with air source heat pump on this as well. So it really shows that wastewater heat recovery has that longevity looking forward into future home standard and further on and beyond. So yeah, very good case study, that one, and I'd encourage you to take a look at the Z House. It really is quite an interesting project. Just touching on the resources, so we mentioned resources earlier. We have full CAD packs, BIM objects, downloads, videos, and everything that goes with our all of the products, all installation products. Online technical CPDs, if this wasn't enough for you, we've got online CPDs that you can work through at your own pace. And as I said, a dedicated learning site, and also the studio that we're here to tailor videos, toolbox sessions, all of those things for merchants and for installers. So, and then just finally, before we hit the 1/2 mark, thank you very much for attending today. Normally these kind of lunch and learns, historically they used to be out on the road with you. We're now moving everything online as part of our sustainability journey ourselves, but to kind of compensate, if you like, for that, the missing sandwich on the lunch and learn, we'll donate 25 trees for everybody that's attended today and fills out the CPD form. So I'll send you links at the end of this, and if you fill that through, we'll donate the trees for you as part of your sustainability journey, but also to sort of promote ours as well as we go through. So thanks very much, everybody. I'll pause there and just see if there are any further questions or anything that for discussion.
Thanks, Alice. Nothing else has come through on the chat. I have put a note in there to say if anyone's got any questions after the session is finished, then they can email through to technical@recoup.co.uk, and one of us can pick that inquiry up. Great stuff. Also, we've recorded the session here today, so with the follow-up email that we send you for the CPD form, we'll also have links for this presentation on YouTube as well, so you can always refer back, or if you want a direct presentation, I can send that out to you. So if there are no further questions, I'll say thanks very much, everybody, and thanks for your time.